Far beyond only recommending which type of interface material to use, we have the expertise to guide you in your whole thermal design process. Our expertise also covers the other technologies for electronics thermal management on the market and how these can be applied to best effect. The thermal design influences many other hardware and even software disciplines in application design, all of which we have familiarity with. Our organization possesses an extensive experience of designing thermal solutions for all subsets of the electronics industry, from advanced high-tech to extreme high-volume consumer products. Our capable R&D organization is constantly advancing our position in electronics thermal management. They can also develop new custom materials to customer requirements. CompuShield extruded gaskets are made of electrically conductive silicon rubber, designed to fit the specific application perfectly. The gaskets are available in any profile and cross-section needed by the customer. Our extruded solutions are cost-efficient and reliable. No wonder CompuShield extrusion has become widely used in all kinds of application areas. Besides the wide range of standard products, we also offer advanced solutions as the CompuShield EE gasket, an efficient solution that combines optimal EMI shielding and safe environmental sealing in one single gasket. Add the press fit feature to the EE gasket and you'll get assembly that is easier than ever. It also improves the shielding effectiveness and eliminates the adhesive costs. With the anti-stretch feature, the gasket has an embedded metal thread reinforcement. This design prevents stretching and shrinking to enable an easier and more secured assembly, just the way you want it. Another popular gasket is CompuShield Soft. Co-extruded with conductive material as the outer layer and non-conductive as the inner. When soft becomes ultra-soft with an even thinner conductive outside layer and a unique ultra-soft core, the gasket maintains its excellent shielding properties, but is also prevented from collapsing in sharp corners. CompuShield Ultra-Soft is ideal for connector applications. Did you know that you can order free samples from our interactive gasket guide online? Quick and easy, and a great way to find your perfect match. CompuShield molding involves overmolding with electrically conductive silicon rubber on various substrate surfaces, for example cans and frames, or just as press-molded components. Our custom molded solutions with high-quality materials and efficient manufacturing methods are used for diverse applications in broad industrial segments. Besides excellent shielding, CompuShield molding provides great flexibility in design and gaskets with high-precision 3D geometry. Co-molding is an efficient alternative where both the conductive and the non-conductive silicon rubber are molded at the same time. This simplified process, with one step instead of the ordinary two, provides benefits such as cost efficiency and stability. The CompuShield molding family also includes CompuShield sheets. The sheets are available in a range of conductive fillers and ready to order in standard size or as die-cut or kiss-cut parts, perfect for connector and waveguide gaskets application. Thanks to our experienced field application engineers, capable in both EMC and the mechanical area, you'll have constant support and guidance through the whole process, from conceptual phase to production startup. Sounds good, doesn't it? Do you want to know more about what Nolato can do for you? Get in touch.
Electronics can never be 100% efficient. The lost power is spent as heat. It's generated by electrons moving through materials. And the corollary is that all electronics generate waste heat. Now, the crucial question is, where does this heat go? Heat dissipated at the rate it's generated won't accumulate as raised temperature and isn't a problem. However, with thermal barriers in the design, the temperature at the heat source will keep rising until the thermal gradient is steep enough for the heat to escape, which can cause problems. And this is where our expertise can help. Understanding how to solve, or even better prevent, thermal issues in a design is never a question of one single component, of one single link in the thermal chain. It is a question of understanding the mechanisms of heat transfer, of following the heat all the way from the heat source to the final sink and removing the bottlenecks. We use thermal interface materials to facilitate the movement of heat from one solid body into another. Putting any two flat surfaces together will never yield even close to full contact. In reality, the direct solid-to-solid contact is something on the order of 2 to 4% of the total surface area. The remaining 90-something% will be pockets of air. Air is a brilliant thermal insulator, and in a thermal interface we don't want that. And that's what TIMs do. They displace the air and replace it with a material with at least 2 orders of magnitude better thermal conductivity. It's all about removing the bottlenecks. Although we specialize in one particular thermal management technology, interface materials, we understand the other technologies involved and how these relate to one another. Therefore, we can assist our customers in their thermal design and guide them to a solution.
Compotherm fillers are liquid dispensed thermal filler materials that are able to conform to any arbitrary geometry and provide effectively negligible component strain, while also being highly adaptive to high volume production. We also have the capability to customize our filler materials by optimizing, for instance, curing times or viscosities to specific customer requirements. For our two-part materials, Nolato has also developed a machine material integrated solution to enable a highly cost-efficient dispensing process. Nolato Silikonteknik uses the ISO standard hot disk measurement to measure thermal conductivity, because this offers a number of significant advantages over the widespread variations of the ASTM D5470 method. The hot disk method uses a thin disc-shaped probe placed in the center of a small sample of material. A current is run through the probe, causing it to heat up. The same probe then monitors the temperature versus time response of the sample with a very high degree of accuracy. Unlike ASTM D5470, the hot disk method is entirely self-contained, in that neither the sample itself nor the test equipment is subject to any other factors such as surface or positioning tolerances, radiative or conductive heat losses, etc., that may have a significant impact on the test result. This also means that the thermal conductivity numbers given by the hot disk method are generally much more conservative than those given by the ASTM D5470 variations. Hot disk test results are also entirely reproducible, as the test method is fully standardized and not found in significantly different in-house variations and interpretations. As the hot disk method provides very accurate data rapidly, we are also able to use the same equipment in our inline QA testing as we use to make our data sheets. Compotherm pads are conformable, thermally conductive silicon pads for applications where heat must be conducted between a component and a heat-dissipating surface without stressing the component, or where gaps need to be bridged. Our materials come in a range of thermal conductivities. Compotherm pads have a natural double-sided tackiness, but with our proprietary technology, we offer the option to remove the tackiness on either side with only a minimal impact on the thermal performance. We can also offer pads with a variety of other customizations, including a choice of reinforcement liner materials such as fiberglass mesh or aluminium foil to answer a breadth of customer requirements.